Okay, guys, this one here is much more complicated than the others because we are looking for the speed of the current. Here's a directional, but it doesn't ask for this, so we don't really need to do this. We don't really need to solve for this theta, okay? We don't need that. So what we have to do here is, because if we set this up, we would actually end up having the law of cosines, because we can get this, right? Because we're going to do this. This is 47, this is 43, this is 47, right? We can do this, but then we would have the law of cosines, and we would have some crazy factoring, which we'd have to use a quadratic formula. What I want you to see is, I want you guys to see all of the right triangles in here. This line here, we're going to call y, is actually the same as this here. And I'm going to show you why that matters in a second, okay? So let's look. How can we solve for this y right here? Well, look at this right triangle that we have here. So that's going to give us the cosine of 43 is y over 35, right? So don't forget, we can still use basic trig. We can still use regular right triangles. You want to find the right triangles wherever possible. So when I solve this out, I get y is 25.6. If that's 25.6, this is also 25.6, okay? Why is that important? Why is that important? Well, I now have this right triangle right here, which I can find this theta. If I find this theta, I can subtract it from 47 and I get this angle in here. If I have this angle, I can do the law of cosines with the 35, the 46, and this angle to get x. So here we're just using our basic trig. So right here, to set this up, because here's our right triangle, this is going to give me the sine of theta is 25.6 over 46. So theta is the inverse sine of 25.6 over 46. Theta ends up being 33.82. So this is 33.82. Well, therefore, if that's 33.82, I'm going to subtract that 33.82 from 47, and I'm going to get 13.18 degrees. So it doesn't always have to be law of sines or law of cosines. You can use your basic trig in this too. Don't forget to see wherever you see right triangles at, okay? So now I'm going to solve this out. I'm going to have x squared is 35 squared plus 46 squared minus 2 35 46 cosine of 13.18. When I solve that out, I'm going to end up getting x squared is 3341 minus 3135.18. So x is actually 14.35 miles per hour. And that is the speed of the current. This was a tough one because we've never really looked at all these different triangles. But you can use any geometric rules you know to solve these things out. All right, so don't be afraid to look for basic trig in this. It's not always law of sines, law of cosines. Most likely you will use it at least one point.